Question 4. A woman pushes a child in a buggy up a ramp as shown below. The woman pushes the buggy up the ramp with a force of 100 newtons. Calculate the work done to push the buggy and the child up the ramp. Okay, so a nice easy one. Work, not weight. Work is force times distance. Force given is 100 newtons. The distance given is 6 meters. So 100 times 6 is 600 newtons. Nice and easy. B. The energy gained by the buggy and child, a mass of 55 kilograms, at the top of the ramp does not equal the work done. Explain why these two values are not equal. In your answer you should follow these bullet points. So let's go ahead and do that. Name the type of energy the buggy has when it reaches the top of the ramp. That is gravitational potential energy, EP grav. Calculate the difference between the work done and the energy at the top of the ramp. So we would use the gravitational potential energy, EP equals mgh, which is 55 kilograms times by 10 times by 1 meter. Now we don't use 6 meters here, even though on there it says 6 meters, because the gravitational potential energy gained is only that 1 meter height change. Okay, so we're going to end up with 550 joules. Okay, and there was 600 joules of, did I write joules? Yes, 600 joules at the top there. So the difference is 50 joules difference. Explain where the missing energy has gone and why this occurs. So the missing energy is gone by combating friction, and friction usually produces heat. So there's energy lost in heat there as well. And we've got to remember as well that when we look up here it says the woman uses 100 newtons to push the buggy up the ramp. You've got to also remember the woman has a mass and she's gaining height as well, so she's having to do work on her own body to lift herself up that high. I don't think the question takes that into account when it's thinking about it, because she would weigh at least 50 kilograms you'd expect, which would be another 500 joules of energy that the woman would have to use. So perhaps when they're talking about the question, the woman's pushing the buggy with a force of 100 newtons, and that's not counting the force she's applied to herself. So either way you can just follow the question and it makes most sense. C. Explain in terms of force and energy, so two key points. We have to explain, mentioning force and energy, why it's easier to push the buggy and child up the ramp than to lift it straight up. Okay, if we had to lift it straight up, okay, you would have to apply a force that was equal to or greater than the force due to gravity, mg, which would be 550 newtons. Okay, 10 times 55. When you're pushing it up the ramp, it may take more time, but overall you use a less or lower force. So you're moving it up a little bit at a time, whereas lifting it straight up you have to at least have 550 newtons to overcome the force due to gravity. Okay, that's probably the easiest way to look at it. At level 2 we might talk about the, no, forget that, it won't work. Okay, so keep it simple, have to overcome the force due to gravity, 550 newtons, versus just a smaller force, 100 newtons, applied over a longer time and a longer distance to get you there. Interestingly, if you lifted it straight up, the work done over the 1 meter is still going to be 550, at least. 550 times by the 1 meter, which is 550 joules of work done lifting it straight up. But 100 newtons applied over a 6 meter lift, you're still going to do around about the same amount of work minus that bit for friction and heat and things. You'd probably have to do more lifting it straight up anyway, because you're going to convert a lot of energy to heat in your muscles and so forth.